Hi everyone, in this video, we will learn about ranges in Kotlin. So, what are ranges in Kotlin? Let's start with a simple definition. In Kotlin, a range is essentially an interval that has a start value and an end value. Think of it like a segment on a number line, or a sequence of characters in the alphabet. Ranges allow us to define a sequence of values. You can use ranges to represent many real-world concepts in your code, such as storing weights, temperatures, time, or ages. One of the main goals of Kotlin is to be pragmatic and concise. Ranges perfectly embody this philosophy by making code shorter, more readable, and safer compared to older, more verbose approaches in other languages. They help eliminate a lot of the boilerplate code you might be used to from C-style for loops. Creating a range in Kotlin is wonderfully simple. We use the double dot operator. Let's look at some examples. Numbers. If you want a range of integers from 1 to 10, you simply write 1. 10. Characters. You can also create ranges of characters, like all lowercase letters from A to Z. The underlying mechanism is that any types that are comparable can be used to create a range. If your custom class implements the Kotlin comparable interface, you can even create ranges of your own objects. This is an important detail for beginners. The operator, which we just learned, creates closed or inclusive ranges. This means that the second value, or the end value, is always part of the range. For example, 0. 9 includes the number 9. This is similar to writing I equals 9 in Java. Prints 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. However, what if you want a range that does not include the end value? For this, Kotlin provides the until function. It creates an exclusive range. For instance, 0 until 10 includes numbers from 0 up to, but not including 10. Prints 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is a great example of Kotlin's focus on readability and intent. You explicitly state whether your range includes or excludes the end boundary. Once you have a range, you often need to check if a specific value falls within that range. Kotlin provides elegant in operators for this. The in operator checks if a value is included in the range. For a value to be included, it must be greater than or equal to the start value and less than or equal to the end value. The in operator checks if a value is not included. Let's see some examples. Prints, is C in the alphabet range? True. Prints, is 0 in the negative numbers range? False. Prints, is 500 not in the large numbers range? True. These operators are incredibly intuitive and make your conditional logic much cleaner than complex equals and equals checks. Iterating over ranges, the loop and progressions. Ranges are primarily used for iteration. In Kotlin, a for loop is simply a for each loop over a range. Integer ranges, which include int, long, and char ranges, are special because they can be directly used in a for loop. When you can iterate over all the values in a range, such a range is called a progression. Printing single-digit numbers. This loop is inclusive 0 to 9. Prints 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Iterating over characters. Prints A, B, C, D, E, F. It's important to note that Kotlin's compiler optimizes these range-based for loops. They are compiled into index-based for loops on the JVM, which means there's no performance penalty from creating extra iterator objects. This is a key example of Kotlin being both concise and efficient. Kotlin also provides functions to customize your range iterations further. Down to. If you want to iterate in reverse order, counting down, you use the down to function. It effectively sets the step to -1. Step. You can specify a custom increment or decrement value using the step function. Be aware that with the step, the last element might not be included if it doesn't align with the step value. For example, 3. 6 step 2 prints 3 5 but not 7, as 7 is outside the range. Ranges with expressions. Ranges become even more powerful when combined with Kotlin's expression, which is a highly flexible alternative to Java's switch statement. You can use in operators directly in when branches to check for membership within ranges. Let's create a function that recognizes character types. Checks if C is between 0 and 9. You can combine multiple ranges. Prints, it's a digit. Prints, it's a letter. Prints, I don't know. This makes complex conditional logic involving multiple range checks incredibly clear and easy to read. Okay, all right, guys. We have seen about range in Kotlin. In our next video, we'll dive into Kotlin's next component. So see you guys in the next lecture.